Welcome to the lecture series on the deep learning. This is Praveen Kumar, Assistant Professor from VFSCR deemed to be University. In previous class, we have seen how an XOR problem is solved with the help of multi-layer perceptron. Multi-layer perceptron. Okay. Today we will see the solution of the XOR problem with especially with some more different weights and activation function, that is ReLU activation function. In my previous videos, I have discussed that what is this activation function and how this will changes the data. I have explained. So, for the details, please watch the previous videos. So, let us see that first we will try to understand this architecture or this multi-layer perceptron network, we call this as. So, these two layers are the input layers. Here we are going to pass the input. So, we are not performing any operations inside this neurons, or even we need not to call them as the neurons. So, as it is, the information will be comes out. Once it is comes out, as we have explained this formula, sum of xi double I wi plus b. This is our formula and we are applying the function on this data. This is the core formula for the purpose of training the network or forward propagation. So, here this activity, this xi is going to be the input and that input will comes out at this point, it will pass inside and it will come out here, and this will be multiplied with this 1, okay. And similarly here the input will pass to this through this x and it will comes out at this point, and this will pass through this line and it multiplies with this 1 and it will meet at this point. So, here what we are going to get is that here we will get x1, this is if I call it as a w1, and this will be x2 and w2. Like these two components you are going to get, and these two components are going to be summed at this point. This is the formula, summing xi and wi. So, this I stands for the 1 and 2 or more number of inputs and more number of weights. So, that way this is going to be one component x1 w1 and this is going to be the second component x2 w2. So, these are going to be added here. So, this formula will become this way, x1 w1 plus x2 w2, then there is going to be a bias, this I am calling it as bias term. This term we are taking the bias as the 0 only. So, plus b, this is going to be the formula. Here just we need to substitute the values, okay. So, this is what the thing, and after this information, this we can call it as a z part, and this z is again passed to a function, and this time we are using a function called the ReLU. So, here up to here this is summation, and here I am using a function, that function I am calling it as ReLU, rectified linear unit. What is this ReLU function is that it is a very simple function. ReLU is 0 comma this is max of 0 comma 1. So, whatever the two values you are going to pass, if the value is either 0 or 1, in the sense if this value is lesser than this 0, you are going to get 0 only, otherwise you are going to get 1. So, here the x value is less than 0, it will be 0 only, and if the x value is greater than 0 or even okay, so 0, then we are going to get 1. So, here ReLU is what it is doing is, it is taking a even negative value and it is converting or it is making it as positive value. And if we have greater than the negative value, as it is that value it is going to pass us. So, that is the functionality of this ReLU one. So, that is why this ReLU activation function is shown in a graph format. This way it will be shown. So, here the coordinators will be the negative coordinators and here you will not get any values. This is starting from 0 point, this one. It starts at this point and it moves this way and it will goes up. So, whatever the highest value you are going to get, you are going to get that higher value only. So, that is the ReLU function, and this is a non-linear function because it is giving us a curve. This way it is giving us a curve. So, this curve what makes us is that one, it allows us to take a non-linearity in the data. So, the ReLU function we are using. So, here also the same thing is happening. You are going to get the x1, you are multiplying with this weight and you are getting the x2, you are multiplying this one, 2 components will come and those are added and this bias is also added, and finally again you are going to pass it to the function and it is going to give the output. So, here you need to understand that one. So, first term we got is this z and the second term we got is this z is applied to the function and we have got a, just we are naming the values like z and a. So, this is my first level. Once my first level happen, I am going to get some output called the A1 and A2. These are the two outputs I got. And these are again converted into, or they are considered as the inputs to the next layer. The next layer is this one. This is my next layer neuron. Here of course, we are using the single neuron and it is possible that I can use here multiple neurons, and single neuron I am using. To this single neuron I am passing again the same formula I am using, xi wi plus b sum of. So, here this is my A1, here it is going to be passed through this line. So, while it is passing, it is going to be multiplied with this weight. If I assume that one, this is my weight 1 and this is weight 2 and this is weight 3 and weight 4, this will become my weight 5. So, A1 W5 and this is A2 W6, because this I am considering it as my weight 6, A2 W6. So, these two are multiplied and they will reach at this point, and here I am going to use my summation along with my bias. So, my equation will become this way, A1 W5 plus A2 W6 plus bias, and this I will consider it as my z part. So, if I consider this whatever I got is this is z1 and here it is z2. So, then this will become my z3. So, here I am going to get my z3. This z3 is passed through a function, ReLU function. So, z3 I am passing it through the function and finally, I am going to get some output. Instead of calling it as A3, I am going to call it as my y predict or y hat, or I am calling it as y pred. Okay. This way, so we are showing it the process. So, now we will take the input of this XOR values and we will put those values into this network, and how this network will produce the output we will see. So, here this is my input and that is my target. So, here you need to understand this terminology. Input we are passing x1 is 0 and x2 is 0 only, okay. And my y target, that is what is it I am expecting? I am expecting is 0, because we know that one the XOR output is, the XOR truth table is 0 0 0, 0 1 1, 1 0 1 and 1 1 0. This is going to be my truth table, and here the truth table I am going to call it as y, and this is as x1 and x2. So, this is my target. So, here what I am doing is, through this multi-layer perceptron, I would like to achieve through the multi-layer perceptron, I would like to achieve this y target, okay. And this output is not a linear output, because here the connection or the values are arranged in such a way that they are non-linearly arranged. So, that is the point. So, at this first level what we are giving is, we are giving this, we are taking this one 0 0 input and we are expecting the output as the 0. So, let us see that the first formula is Z1 equal to x1 into W1 plus x2 into W2 plus B bias. Just now I have explained you, and if I substitute my values, so my inputs are the x1 and x2, those are all given in this color. So, these are two my inputs, and my x1 my W1 and W2 are the 1 1 in red color, and my bias is a bit green color. So, when I apply this one, my output I got 0, and this 0 I passed it to the ReLU function and I got my A1, and that my A1 is 0. So, here my intermediate output I got. So, that intermediate output is at this particular position after applying this entire function, okay. So, I got this output. See this one Z1 and A1. Similarly, for the next layer. So, here if you observe, the things are happening. So, this way, this is one operation happening. So, the same thing is happening, same values are sending to the next layer and here, and at this point we got this A1 and A2. This A2 is this one. So, now what we are doing is again the same x1 and x2 passing, but we are multiplying it with the different weights W3 and W4, and when bias is taken as -1. So, the output I got is -1 at z point, and when I passed this to the ReLU function, I got output 0, because what this ReLU will do, ReLU will take any value, and if it is -1, it gives it as the 0, and if it is greater than the 0 or equal to 0, it is going to produce 0, because the function is like that, max of 0 1. So, it is going to produce 0. So, we will get the output 0. So, at this A1 point we got value 0, and at A2 point we got value 0. These two are the intermediate results for us, and these results we are passing it to the next layer, that is my next layer. Here I am having only single neuron, okay. There is absolutely possibility is there that I can use more levels, but to explain you this one, at this time I am taking only a single neuron at this particular layer, and I am considering it as my output layer also, okay. So, this is my hidden layer or intermediary layer, and there is a possibility that here I can have n number of multiple layers, and this is going to be my output layer, and even it is possible that at this output also I can have multiple neurons, but this time to make it simple, we are using single neuron. So, again this is going to be passed through that weights. So, these weights are going to be 5 and the 6. See this weight 5 and weight 6 and A1 and A2. So, the values are substituted. So, the weights W5 is 1 and W6 is minus 2 and bias is 0 and I got is 0 and my ReLU output is 0y and this 0 is because it is my 0 value. So, I got the output is 0. So, the final output I got is 0, which is expected one, this one. Okay. So, ultimately what we are concluding is that with the help of the multiple layers or using a hidden layer, I am achieving that when I give this 0 0, my output is 0. Okay. Let us see with the next input and the target. Let us continue with this example. Now, my second input is x1 is 0 and x2 is 1 and my y is expecting 1. So, for this one what we are doing is again we are performing the same operations. I am calculating my z1 by using this formula x1 into w1 x2 into w2 plus b and I am substituting my values. Again my x1 is 0, my x2 is 1, this one and my weights are 1 and 1 only and my bias is 0. Here the weights are not modified and the bias is not modified. Only the modified thing is that input and the target is we are expecting the output. And we computed the z1 and this z1 is passed to this ReLU function and ReLU has given me 1. So, ultimately my A1 value is became 1. Similarly, when I calculating this z2 with the help of the weights W3 and W4, my inputs are 0 and 1. So, I got the z value is 0 and this I pass it to the ReLU function and ReLU has given me 0. So, my intermediately results are 1 and 0. These two are passed through the next layer. The weights are W5 and W6. Inputs are 1 and 0. These are my inputs 1 and 0. These are multiplied with the weights, weight 5 and the weight 6. Weight 5 is 1 and weight 6 is minus 2. So, with this one I got is 1 and this 1 I pass it to the ReLU function and my y value I got is 1 and this 1 is expected target. So, we have achieved it. So, to the same network when I pass 0 0 I got the output 0 and to the same network when I pass 0 1 I got output as the 1. Okay. So, let us see the last input. So, this is a different thing. When I pass 1 and 1 I need to get 0. So, this magic should happen with the help of the weights. So, the weights are already arranged. Let us see that what is happening here. So, my x1 and my x2 are 1 and 1. My weights are 1 and 1. So, 1 into 1 plus 1 into 1 plus 0 and this I got is 2 value, 2 is my z1. This 2 I pass it to the ReLU and ReLU returns the same value. So, I got this 2 as the output at first intermediary level. Then when we calculate this z2 part, my x1 is again 1 and x2 is 1, W3, W4 are 1 and 1, bias is minus 1. So, I got is 1, this 1 I pass it to this ReLU function, ReLU has given me 1. So, my A1 is 2, my A2 is 1. Again these two are passed through the network and finally, we are going to calculate this y part. So, here we are using my W5 and W6. So, that thing here my W5 is 1, my W6 is minus 2 and inputs are 2 and 1, that is A1 and A2 I have computed this formula. So then I got this Z3. This Z3 I passed it to the ReLU function, and ReLU has returned me my Y value, and that Y value is 0. So surprisingly, okay, so we have got when we give the 1 and 1 as the 0. So here the point we need to understand is that this is the only network. I will clean up this one. Right. Okay. This is the single network we have followed, and using this network we have achieved XOR. When I give 0 0 0 and 0 1 1 and 1 0 1 and 1 1 0. So if I have shown this one, my 1 1 is 0 and 0 0 is 0. Sorry, 1 1 is 0. So I will put 0 here, 1 and 1 here. I can show this output on a graph this way. So this is achieved in the sense the border is a curved border is managed to draw with the help of the multi layers. Okay. So this is the great advantage of the multi-layer perceptron. And here the magic is happened with these things. The weights which we have used, those are the W1, W2, W3, W4 and W5, W6. And even the biases also 0, 1 and 0. So here we have not discussed that from where we have or on what basis we have chose these weights. Okay. We have randomly kept these weights and luckily we got the output. If I have changed these numbers in a different way, certainly we may or may not get the output. So here the crucial points have become are these weights, and we have not decided these weights, or we have not discussed that how to find these proper weights. So for that one, in previous class I have discussed one algorithm called the back propagation algorithm. So this algorithm will help us designing those points. Okay. So here what we are doing is we are calculating the loss. So let us see this with some example. Here my expectation is this one. Okay. I would like to give input 1 and 2, this is my x1 and x2, and I am expecting my target as 1. So the question is that one, when I pass this 1 and 2 as the input to this network, I am expecting the output as 1, and we will follow the same procedure which we have applied for the XOR problem. But whatever the weights here we have taken are not giving me the exact answer. So we have to see that one. Okay. So for that one, what are the steps we will follow is that we will perform the forward propagation. We will perform forward propagation. When we perform this forward propagation, all steps, that is computing this A1 and A2 and finally computing this y hat. Okay. When we check this y hat, okay, if this is not equal to this 1, it means that because of which reason we have not achieved that 1 means because of this weights and the biases. So we need to adjust, or we need to find out the suitable weights and suitable biases so that we can achieve the target. So that is the intention, and finding out that expected weights is called the back propagation procedure. So, here for this thing, first we will perform this forward propagation. Again, forward propagation, as just now I have told you, the same process we have to follow. We need to multiply the inputs with the weights and we need to add the bias. So, when I do this one, so my inputs are 1 and 2 and my weights I have taken 0.1 and 0.2 and my bias is 0.1, the total output I got is 0.6. And when I pass this 0.6 to this ReLU function, it is producing me 0.6 because it is a positive value. So, I got my A1 as the 0.6. Similarly, I am doing multiplication, or I am performing this activity for Z2. So, I got the 1.2 and I passed this one to my ReLU activation function, I got A2 and the output is 1.2 as it is positive 1. So, my A1 is 0.6 and my A2 is 1.2. So, these two are passed to the next layer, multiplied with the weights W5, W6 and added the bias part, and finally, I got this 1.12. So, my Y prediction, or I can call it as Y hat, is 1.12. So, what is my target? My target is 1. So, instead of getting this 1, I have got the output is 1.12, which is slightly more than the expected thing. So, who is the culprit, or who is the reason to get this one? So, here the output I got is 1.12, but expected is 1. So, who made the mistake, or what is the mistake in the sense, whoever with which values we have multiplied these inputs, the weights, the 6 weights, okay, and 2 biases, even the activation function. Okay. These are the responsible persons to get this output. So, this output I need to bring back, or I need to drag it to the 1. I need to reduce this 1.12 to 1. I need to make that 1.12 to 1. To make that one, I can change, or I have to change the 6 weights, 2 biases, activation function. These are all playing a role. These all values are playing a role in reducing this 1.12 to 1. So, we need to figure out that what are the suitable values or correct values to figure out that 1.12, or to bring down that 1.12 to 1. For that one, our next activity should be computing the loss. So, step 2 is computing loss. So, here we need to follow one loss function, and at this time we are following the mean squared error loss function, that is half of Y prediction minus Y true square. So, what is my Y prediction? 1.12 and my Y true is 1 square and divided with the 1 by 2. So, ultimately what I got is that, okay, so 0.0072 is my loss. So, the thing is that the statement is that expected is 1 and we got is 1.12. So, the mean squared error or the loss is 0.0072. I need to adjust my weights such that this 0.0072 become 0 or very close to 0. So, that is the intention, or that is the aim. Okay. So, that activity we are going to call it as a back propagation, and that we will discuss it in the next class. Thank you.